Okay, welcome to the introduction to software engineering class. Today's lecture is about software design and implementation. Okay, we discussed about software design already on the last lecture, and today we will discuss about software design and implementation. How can we transform from requirement to software design and to implementation? As we understand that the main point of the software design is to try to translating the requirement model into the design model. Okay, there are many design model level. As you can see here, there are component level design, interface design, architectural design, and data and class diagram design. Okay, if we can see this figure that they are mapping between the analysis model to the design model. You see, if we want to design the interface design, okay, including the component interface design and UI design, you have to look back to the use case diagram, swim lane, and sequence diagram to use that diagram to design the interface design. You want to design in the level of architectural design or high level design, you can look back to the class diagram, analysis package, or collaboration diagram to design the architectural design. Okay, there are many diagrams. There are 13 sets of UML diagram that we will discuss already, and some only a few that essential. Only a few that there are 5 that become famous to use, and the rest is not too famous. Software design process, as we discussed, is iterative process that try to what we call which requirement are translated into a blueprint for constructing a software. It means that we try to translating the requirement from the user's requirement and system requirement to be a blueprint that we use for constructing or creating the software. Okay, the blueprint is represent the high level of abstraction. They represent something that in abstract level. Okay, one blueprint can be built for many objects. For example, a blueprint of house, right? So we can take the blueprint of house, can create several objects of house, such as a house itself. Okay, that abstract can be used for what we call for specify the data functional and behavioral requirement. This is a designing process. The main point of designing process is to translating the requirement into a blueprint for creating a software. We have many design concepts that we will discuss. The design concept that we should and recommended to follow when we want to design the software, such as abstraction, architecture, patterns, separation of concern, modularity, information hiding, functional independence, refinement, aspect, refactoring, object-oriented design concept, and designing class. This is the basic fundamental of design concept that we want to design something. This is recommendation and guideline that we have to we need to follow. We want to design any kind of software system. We will discuss about designing model that include data element, architecture element, interface element, component, and deployment element that used to build the design model that we represent in terms of UML diagram, that standard one. Okay, if we look at this figure that we discussed, they are in abstract level, that high from abstraction level to the concrete level, from analysis model to designing model. You look at carefully, at the top is higher abstraction, low is mean that it's become more concrete to the design, to the code. Okay, If we want to, if they are in analysis model, they are class diagram. In design model, they are also class diagram also, but they are a little bit more in design. They add more detail about the class diagram. In use case, also we use use case diagram to translate the use case to be interface design, whether component interface or navigation design or GUI or graphic user interface design. We use class diagram to create a component diagram in the design model. Okay, this is our discussion from the last lecture. We discussed about architectural design, that including design decision, architectural design decision, architectural view pattern, and the application, what kind of architecture that can be application to any software. How can we apply to the software that we discuss. Software design and implementation. Before we do implementation, we have to design, especially for large system. If we are talking about the small system, this is software design and implementation will be the main point of the activity or process in the software system development. Like if we want to do any kind of software, if we are doing some small or medium software, the software design will be the first step that we will consider to design something. Okay, because of designing, you can see in terms of view or visualize or modeling something, rather than see the requirement list and just only take display, right? It's better by using by visual. Okay, software design consists of design principle, concept, and design practice that we have to follow. Such design principle that will establish you, will guide you as a recommendation, philosophy, a guideline that you have to perform during the design phase. Design concept, the mechanism or the way how you have to follow as architecture concept, a pattern concept, a component concept, and so on. Design practice is the way how to construct the design based on various way of design, such as object-oriented approach and so on. You can see here software in design engineering layer. In software design engineering is a process. Okay, if we look at the method layer, we have to design, right? We have to design method. There is object-oriented design and structure design. Mostly right now they are focusing much about object-oriented design. We can see several applications, especially for large a framework, a library, or component, they enhancing the object-oriented design much. Software design is in the generic process. We can see that the design to development, right, or implementation. You can see here. Because we discussed about architecture design is high-level design, so we want to do something more specific, add more specific detail. So we have to discuss about low-level design. There is talking about design pattern and component design. Okay, if you compare, the design can be separated into two levels, right? There is high-level design and low-level design. High-level design, they are focused about architecture design. In low-level design, they are focused about design pattern and the component design. Design and implementation. Today, our class will discuss about object-oriented design using UML, design pattern, and the implementation issue. Okay, when we try to do implementation, there are some kind of issue that we have to consider before we do implementation. Design and implementation. The software design and implementation is the process in the software engineering process at which an executable software is developed. This is the software design. Actually, if we consider about the software design and implementation, if we are consider in terms of small scale of development, software development, we can combine these things together. But if you are developing such a large scale of software, so these two steps will be separately. Okay, will be software design is another step and implementation will be another step. If you are develop some kind of small application, so this step will be the same step. Okay, software design and implementation activity are invariable interleaved. It means that it takes from the requirement and requirement gathering, requirement analyze and design and do the implementation. As they say here, software design is a creative activity in which you identify software component and their relationship based on the customer requirement. Mean that we design something based on the customer requirement. Okay, especially we design the software, we try to identify the software component. Okay, a software component is a set of a class and interface that talking to each other. Okay, implementation in the process of realizing the design as a program. This is the meaning of implementation. We try to constructing from the abstraction level to the a program that can be runnable. Okay, it can be run, it can be useful. There are a debate about software development. You will build or buy. Okay, it depends. If you build, mean that you have to getting the requirement from the user, designing, analyze and design and build. Okay, if you are buy, you can see the requirement from the user and then you can see the another person already they are using that system and then their work, so you can adjust to your organization. For example, here if you want to implement a medical record system, you can buy a package that is already used in another hospital. It can be cheaper and faster to use this approach rather than developing a system in the conventional programming language. So if you see, if you compare about the feature that you are using, there is if you are developed from the scratch, from gathering requirement, analyze and design, it may be expensive than buying. So better to buy the package. Okay, we call off the shelf system. Okay, or cost. Okay, this is the buy or build. It's not everything you should buy, it's not everything you should build. It depends on the what we call project management and configuration and some budget that they are ready over there. The main point is the deliver the requirement, a system requirement. Okay, the main point is to serve the user and system requirement. That is the point of the buy or build. Okay. Object-oriented design using UML. Now we discussed many already about UML and object-oriented design, and we know that there are many types of UML, right? There are 13 sets of UML diagram that we can use to do design and analyze. Let's see here what we will discuss for this one. Okay, an object-oriented design process. We try to use the object-oriented design. You can use UML for another approach. And this one we're talking about object-oriented design process that involve a number of different system model. They require a lot of effort to develop for maintaining the model. If you are developing the large system, it's okay to use UML. Okay, but also if you need even medium or small application, if you need something that communication mechanism for making understanding at the same point in your team, that's better to use object-oriented design by using UML, right? Because it can be effective to talk to your people, to talk to your team member that the application should look like this, rather than you just imagine and drawing without any standard. Because of what? Because of they may not understand your design sketch. They may not understand your idea. if you do not explain in terms of standard modeling. Okay, this is the main point of the object-oriented design process. There are different and many processes that can be done by using object-oriented design, but this is the generic and then the common activity that when we try to use object-oriented design. Okay, there are 5 here. First is define a context model. First is define the context and mode of the system. Okay. The second is design the system architecture, and the third is identify the principal system object, and the fourth it will be the develop design model, and the last is specify object interface. Okay, the first is about the overview of the system, how the system is related to another system. Okay, and the second is about architecture in that system. Okay, the system architecture design, what the architecture pattern or style that you're going to use for that system, and the third will be the identify the object. Okay, how many object will be related to this system? There are maybe subsystem inside this system. Okay, develop design model. So there are many design model as activity diagram, class diagram, and so on. And then the last one is about specify object interface. We have one word that many developer and software architecture and design software engineers say that the code to interface. You should define the interface, because interface will provide you the way how you going to use, how another people going to use your object. Okay, or your object of your component, because you will not show the detail inside the component, but you will show the interface, right? That what this interface doing for. Okay, what this interface using for, but they will not understand the inside, how they going to calculate the inside inside the component, right? That's why we better to use interface. Okay, system context and interaction. The main point of system context and interaction is to see, to understand the relationship and the behavior environment around the system itself, because a system do not operate based on itself, but they are depend on some kind of another system. Okay, this is we have to look back to another system, that how many systems that related to the system we are going to develop. Okay, understand the context also let you establish the boundary, the system. They can see that how many, I say that how many systems working together to the system. This is we call system context and interaction, how they interact to another system. Okay, for example, we have system A and B and C. Okay, we are trying to develop system C. Okay, system C may depend on or working with or interaction with the system B and A. This is what we are talking about. Okay, context and interaction model. There are two types of context and interaction model. The first is structural, and then the second is dynamic model. Structural is it represent what we call the model, demonstrate the author system in the environment of the system being developed. So it will see how many systems that working together in the environment. Okay, we're going to develop just only one system, but that system may depend or working with another system. So we have to describe our system in terms of structural model. And an interaction model is dynamic model that show how the system interact with the environment as it used. Okay, it will see that how they interact to another. Okay, this is example of my research under the topic of the impact of design pattern in refactoring technique to measure performance efficiency by me. Okay, I published on this my thesis in 2017. You can download the code via GitHub that I given the link to you already. If you look at here, there are many systems working together, right? This is I say the component diagram of academic information system architecture design. This is the example of academic information system that try to serve the user, a student, lecturer, or university or college about academic information. Okay, there are many systems inside. For example, we have SIA plugin, SIA domain, SIA service, SIA data, and so on. If you look at here, they provide the interface, right? They talking to another component or another system by using the interface. This is the main thing that we discuss: system, context, and interaction. Okay, if you are interested to do the reverse engineering about this project, you can search on the GitHub. Okay, github.com/langsari/SIA-project. Okay, I give in everything about the code. The project is written using J2EE, Java 2 Enterprise Edition. Okay. The example of the weather station, you can see this is the system context of the weather station. You look at the right hand side, there are weather station. The weather station, they're not working alone, but they are depend on another system. This is we call system context. Okay. They may depend on control system, satellite, weather information system, and so on. If you look at here, you have the many, we say the feature of system, right? There are many features that we can see here. I list the feature. The interaction, actually this is about interaction of the use case diagram of that system in doing the reverse engineering. Okay. If you look at this one is weather station use case. This is interaction of the weather station by explaining by using the use case that interaction of the people, okay, actor to the use case. One people may interact to many use cases. Okay, for example, here we have report weather, report status, and so on. Okay, with two actors. Okay, you look back to the project that my thesis, you will see there are 14 features that I list there, and then there are 5 actors over there that using different feature. They can be access different feature based on their role and permission. Okay, this is about interaction. Okay, system context and the interaction of the system. If you look to use case description, this is another the way that we explain our design. Is we use use case description for the report weather, right? The first use case of the weather station, right? We have report weather, we call a use case, and then when we have the use case, we have to the way we describe the use case, what this use case is about. So we use use case description to describe. You can see here the system name is weather station, use case name is report weather, and then we there actor description, stimulus, and then response, comment, and then the flow of data, and so on, pre-condition, post-condition, and so on. There are many based on the SRS description. Okay. Architectural design is we use this one to design the big or the huge system, the overall system. As we say here, we use the system context, okay, to the information of system context to design the system architecture. Okay, the main point of architecture design is to identify the major component, how many components inside the application or the system, okay, to make up the system and their interaction, and then may organize the component using architectural patterns such as layer, client, server that we discussed. Okay, for example, here we discuss about weather station project, right? implementing the architecture design as we say lighter architecture pattern. Okay, as you see here, this is a lighter architecture pattern that they are using a subsystem. Okay, the weather station, they compose of many subsystems. Okay, and the subsystem working together, communication via the link. Okay, via the link, we say the communication link. If you look at here, there are many subsystems. Okay, subsystem there is collecting by using package diagram. Okay, another name of the UML diagram is we call package diagram. You see the figure look like folder. That is we call package diagram that consists of subsystem, and then from that subsystem you have to do what we call analyze and design again in that subsystem, because there's only one. The subsystem is another system itself, right? In the subsystem there are their own architecture design also. This is the example of high-level architecture of the weather station. You look at here, there are many subsystems, right, that represent in terms of package. Okay, package diagram. Okay. If you look at my thesis, okay, there are many subsystems in one in a system. Okay, they compose many subsystems. You can see here there are the framework. Okay, academic information system framework. They consist of modules. Okay, they consist of database. They consist of academic framework, system framework, and external database, and so on. This is we call system architecture design. Okay, this is overall of the system. Okay, you look at here the module. Okay, the modules, they connect to the database, right, and then the system framework of academic information. You retrieve the module to use, okay, to display to the user, respond and take request from the user, and then reply back by request by response. Okay. Another more deeper level of the architecture design. This one you can see design of the module penilaian, or we call grading. Grading system. Okay, giving the grade for a student. Okay, this is the architecture of that thing. Okay, the grading system architecture. You look at here, because this system is using the Hibernate, and then they are using a Spring framework from Java. Okay, Java to EE. Okay, so the Java J2E Spring framework, they implement the MVC also, but not the what we call the strong or tight MVC, but loosely coupling MVC. So they are becoming a layer. Okay, you look at here, there are controller layer, there are service layer, and the repository layer, right? That the repository is about connecting to the Hibernate, that is the framework that you use to connect to database. Okay, the front end, back end database that I make the reverse engineering from that system. Okay, CIA project or CIA system. This is example of the data collection weather system. Right, we have you look at here, we have a data collection, right, a subsystem of the weather station. After we already get the data, a subsystem, a data collection, we have to go and look and design again a data collection. What inside the data collection will consist? It means that the component inside the data collection. Okay, here we have transmitter, receiver, and weather data. Okay, weather data that we're going to take for each component and design it again in more detail. Okay, in more detail. If you look at again on the same thing here, you look at here, the high-level architecture of weather station system compared to my research. This is one of they are represent in terms of package diagram. Okay, of grading module. Okay, there will be a module that using the notation and graphical notation and using line the relation between each other. Okay. You look at here, there are many packages, right? So for each package, there are different way different responsibility, different interface that working together via interface, right? Okay, this is the example of when you do reverse engineering, you will got this thing, okay? You will got this thing. Object class identification, we have context system, we have the architecture design, we have the component, right? So we have, for each component, we have to identify the object class, okay? As we know, a class is represent the blueprint of the system, right? As we can say here, identify object classes is often difficult part of the object-oriented design, because it depends on the experience and skill and domain knowledge of the system design or software engineer to identify what object class that will include in each component. Okay. To identify the object class it will not be complete at the first point, okay, at the first start. So you no need to make everything perfect at the first part, okay. So you can do it and then redo it again and redesign, okay. This is the way we do of identify the object class. There are many approaches to identify the object class, okay, using grammatical approach based on the natural language description of the system. If you look at the requirement, right, they are in natural language description of the system. So we take that sentence and then try to identify the object, okay, based on the different identification of tangible things in the application domain. What thing that related to the application, so we take that thing to identify the class. Use behavioral approach and identify the object based on the what participate in the what behavior. We can see what they are interacting, what thing that will take action that are interact to that system. That is, we can identify as object. Also use we can use a scenario based analysis. The object, attribute and method in each scenario are identified as use case diagram. There are scenario over there, right? We can take that for each use case to become the class diagram, okay, class diagram. The output of the object identification, okay, the object class identification is a diagram, okay, the class diagram. For example, here about weather station, we identify by using based on tangible hardware and data in the system, mean the data that by using language, okay, natural language. So we can specify for many things, okay. For example, here the ground thermometer, and then weather station, weather data, and so on, okay. You look at the object of the context and the sentence inside the system or behavior of the system, and then we can define the object, okay. That's why they say most of identify the object class is based on skill, based on experience of the software engineer, okay. Example here is the class diagram interaction with another class, okay. We have 5 classes here in the controller, in the service, and the repository. If we look at here, we can see that identify the class by using reverse engineering is easy, because the code are available over there. We just reverse engineering and then we can identify the class name, the class property, and the class method, okay. This is easy, okay. This is easy, but you have to be experienced and you have to learn the skill how to do reverse engineering, okay. The weather station object class, okay, this is the class, the object class that identify for the weather station by looking for many resources, okay, and then we can identify such like this, okay. The object class, including the first is a name of object class, and then the second is the property of the object class, and then the last one is the method or function of the object class, okay. If you look at here, from the requirement to analyze and design it, day by day, it's going to be what we call near to the code, okay, near to the what we call the code to program that can be run, right? Because of what? Because we try to translating the human speaking or natural language to be a computer language. There is programming language, right? That's why if you look at the requirement something that natural, very natural language, right? That user and system used to display, used to describe, right? Then we try to translate, and by using many model. Up to now we have the class diagram, right? That is, we can use this thing to convert to the code, okay? You can convert to the code. If you could look at here, if you have experience about object-oriented programming, right now if you look at this diagram, oh, I know how to write the code, right? For example, weather data, right? I can say that class weather data, and then the property will be air temperature and so on, and the function will be collect and summarize, right? This is more easier, it's near to the programming language, okay? Design model, okay. The main point of the design model is to what we call to see the entity of the inside the content, that how they interact, how they what we call how describe and interact with each other, okay. The design model can be divided into two types, okay. There is there are structural and then dynamic model. Structural, actually they used to object class and the relationship, okay. Describe the static structure, mean that there is no interaction to another, okay. They just show the object class and the relationship to another. You want to display something, the interaction that send the request, send the message to another, and then another object reply back. So we have to use dynamic model that use to what we call to display the interaction between objects, okay. Example of design model, we have a subsystem model that we already discussed, right? Subsystem model, that a system consists of a subsystem, right? So we identify and then display in terms of package diagram and then component. And then if we want to object interaction, it's better to use a sequence diagram or sequence model to see the interaction between objects, okay. From object A to object B, how they interact, how they send, and how they reply, how they verify the message, okay. We can use a state machine model that show how individual object change their state in response to event. For example, they have event sent to one object, how they change the status. So we have to use the state machine diagram. There are many models that can be included in design model, such as use case model, aggregation, generalized, that used to what we call explain the relationship between object or between class. Subsystem model, okay. One system, it depends on, it can be composed, organized into a related group of objects. This is we call a subsystem, okay. Subsystem mean that they compose because one system composed, organized in by many groups together become a system. So we call a subsystem, okay. That small point of the system we call a subsystem, okay. In UML, they are shown using package diagram, as I showed to you, okay. Package diagram that encapsulate the construct. The package diagram, actually they will grouping the component together, okay. The component or object together. For example, here the package diagram of the system, okay. Academic information system, they consist of many package diagram, right. This is the overview, the big picture of the system, okay. How many plugin, how many services, how many components inside the package diagram, okay. In the big package diagram, they may compose of another package diagram. If you look at here, there are a framework, right? You see a framework, they consist of another packet diagram, right? Inside that packet diagram, they may consist another component, okay? They may consist of component. It depend on the design is depend on the skill and experience of the software engineer, how they will do the design, okay? Sequence models, okay? We use a sequence model show the what we call object interaction that take place, okay? We use the sequence to see the how they interact between one to another object, okay? Actually, they are interacting by using the message, okay? They send the message to another, okay? And then another object will validate the message or reply back, okay? By using, they will present in terms of time, they present in terms of label arrow, and then the rectangle box, something like this, as the example here, okay? You look at here from client, right? This is from client. I wanna send a request, okay? JMeter, which is one of application that used to test the performance of the application, okay? I using JMeter. You can search on the Google, you will see this one. I send from the client as developer, this is client, or as the application itself, JMeter send request to the web application, okay, that store in the server, okay. This web application is here, okay, to the web to the web application in the server, and then the web application will respond back, okay. You see that there are times, okay, there are lines, there are arrows, okay, over there. When you send, there will that arrow, right? And then if you return back, there will be another style of arrow, okay? There are also, when you send, a client will send the virtual machine request connection, okay, to the Java virtual machine to see the result, and then it will reply back to you, okay? And then client will talk and then save and collect the data based on the reply of the server, okay? This is the sequence diagram of the performance measuring, okay? Because my thesis is about to measure the performance of the application, that this application can be handled, how many connection, how many concurrent, how many user, okay? Within it depends on it. We say responsibility and the quality of the application, okay? This is example of sequence diagram of data collection, okay? You look at here, weather information system, they display as actor over there, send some requests, okay? For example, the same report, okay? If you look at weather data collection, right? In the, you look at here, weather collect, right? We have a collect over there, right? Report or some things, okay? They send, they will use that method, okay? The method that use, for example, request, the weather information system request a report at the satellite communication, okay? And then satellite communication will report the weather to the weather station object, okay? And then it will get some summary from the communication link, and then we send summarize, okay, request summarize from the weather data, and then it will reply back. You see this one, okay? People will communicate by using satellite communication, right, to the weather station, to the communication link, right, as you see in architecture design, as there are communication link, right, that communicate to another subsystem, okay? And then over there are weather data subsystem, okay? So weather data subsystem that is inside the data collection, and then it will reply back to the user. Okay, this is the sequence diagram that used to describe the interaction, send and request the message from one another object to one to another object. Okay. Remember that every request they should be respond. Okay, whether is correct or error, they should be reply something. Okay, should be reply something. State diagram. Okay. The state diagram used to show how objects respond to different service requests and the state transition triggered by this request. Okay, yeah, the state diagram actually we used to see when we send some kind of event or message to an object, and then it will change the status or stage of that thing. Okay, for example, we send some kind of restart. Okay, it should be restart. They will reply back to you, shut down, right? Something, right? Okay, restart, and they will restart, and they will shut down or not, something like that. Or you will send something else. Transmitting data, for example, they will send back to the data. Okay, this is a state diagram that used to display the state, okay, of the object when we send some kind of message to that. You see here weather station, the state diagram. We have many states, right? We have running, testing, collecting, summarizing, control, shutdown, configuring. Okay, most of the keyword they are using is verb, right? That used to tell something to do. We call stage. Okay, for example, shutdown, I send to restart to running. They will send to shutdown. Okay, because when running, right, and then when I send shutdown to shutdown, it will reply back. They are going to restart or shut down, something like that. This is they will show the action or the stage that running the system. Okay. Interface specification. There are many kind of interface that used to describe the component. Okay. The main point is about the interface of the component that try to identify the object interface. That so the object and other component can be designed in parallel. Okay, when we're talking about interface, because of object oriented, they encap the data, or we call information hiding. They will not show you about the data inside the class, right? Inside the component. So they will provide just only interface, right? Interface in and interface out mean that they will receive your request and then they will respond you by the result. Okay, this is the interface. Okay, you are doing coding, actually they will they are the same way, because we are using the same principle, right? Object oriented analysis, object oriented design that we are talking now, and then object oriented programming. Okay, they are same principle. They're sharing how to implement the object oriented. Okay, you wanna identify the object. So better to use interface, because of what? Because by using interface, it independent from another object. Okay, it will not depend on anyone. Okay, so it can be easy to do refactoring or doing something change from another. It will not affect to another. Okay, for example, interface component 1 with component B. Okay, if you are depend component 1 and component B, so when you adding some kind of any component, right? For example, you editing, or you make changing to component B, it will change to it will affect to component A, right? So by using the interface, they will not depending on any. Okay, they will not depending on any. So you can design the component itself. It what we call self-organized. Okay, you know, use via the interface. Okay, to display the interface, you may use class diagram to represent. Okay, to represent. But we are talking about in terms of design implementation, in terms of high level. We are not talking about any programming such as Java or PHP. Okay, so by using ML to display the class diagram is much more better, much more abstract. Okay, then it can be used for many programming language. This is an example of weather station interface. There are here there are two interfaces: reporting and remote control. Okay. You look at here, the interface, there is no property, there is no what we call the interface doing about. Okay, but they will say about the name the interface. Okay, if you wanna use this interface, you have to implement the method by yourself. Okay, this is called interface. Design patterns. This is the low level design. the pattern of to solve some kind of problem that always occur. Okay. If we look at design pattern, it look like the architecture pattern or architecture style, but it solve another problem, that is a low level problem. Okay, problem. The pattern itself, it will display reusing abstract, okay, knowledge about problem and its solution. I think that we are not the first person talking about software engineer, right? There are many people over there talking about software engineer, and then they try to do many application, many system. We think that do you think that they did not face any problem? Of course, they will face many problem, right? Then they will face the kind of problem there. For example, problem 1, problem 2, and problem so on. And then for each problem, they have to find the solution for that problem, okay? And then this solution will be the common solution, that will be best practice, okay? The solution for that problem we call design pattern, okay? Design pattern. If you face the same problem with them, you don't need to try to solve the problem by your own way, but look at the knowledge that they represent already, they show us already in terms of design pattern. Okay. Design pattern and pattern languages are the way to describe best practice, good design, and capture experience in a way that it is possible for others to reuse this experience. Okay, because another people may experience about this problem, so they try to describe, okay, they try to explain us, if you face this problem, better to use this way, okay. Another person also may face the same problem, and then they try to describe, this is maybe the way to solve this problem in terms of good design and best practice. They should come and discuss and then propose something that we call pattern. Okay, that's why pattern is very important, and then it's useful if you look at any library or any framework that are available right now. They are implement about pattern much, especially framework, okay, library. Okay, the pattern will describe you in terms of, actually they can describe you in terms of text. They will consist of many elements that they will talk in the same language, okay? Because we need to understand, when we face the problem and then we found the solution, and then that solution that can solve that problem, when we want to describe to another people, we have to talk in the standard way, okay? This is the standard way of the pattern element when we want to display to another, okay? The first element is here, the pattern should consist of name, okay? The name should be meaningful, okay? Problem description. When you face the problem, okay? And then you see this kind of problem like this 1, 2, 3, 4, 5, and then you propose the solution, okay? For that pattern, okay? And then consequent the result, and then trade off the risk and the thing that you will get from risk, and the risk will when you apply this one, okay? We apply this pattern. For example, the pattern name observer pattern, okay? The name is observer. The description is separate the display of object state from author itself, okay? The problem is used when multiple display of states are needed, okay? Solution description says you can UML description actually. Consequent optimization to enhance display performance are impractical, okay? So it will be useful when you want to display in different form of display but using the same data, okay? We can use the observer pattern, okay? And this is the pattern element. When we describe like this, okay? The more detail about the observer pattern, okay? The name description, the problem description, they will add more detail about the pattern, okay? And they will include the pattern name, description, problem description, solution description, and consequence, okay? The main book of the design pattern is A Gang of Four, okay, by Eric Gutma. Okay, they talking about the design pattern. They found that this is the pattern for solving the general purpose. There are many over there. There are more than 40 patterns that you can use to solve the problem. Okay, this is one of pattern. Okay, there is observer pattern. The name is observer. Okay, to solve what? To solve as displayed here, this kind of any problem to separate the display of the object state from object itself. Okay, if you look at the figure, it's more easy to understand. For example, you have a subject of this data, right? And then observer 1, observer 2, you can take this data to display in different way, right? Okay, actually with our pattern you have to separate the subject, right? You may copy the subject into two subject, right? And then you display into the pie chart and bar chart, right? With duplicate data. So you can use the observer pattern, okay, to retrieve the same subject and display with different graphical representation, as here is pie chart and bar chart. Okay, this is the observer pattern. Okay, in the code, for example, here there are subject over there. You use observer. You can take what we say the update. Okay, update function, and then you can create a concrete observer, concrete subject. Okay, you create concrete subject. They will they may affect to the subject itself. Okay, it's better to use observer to take the action override of the subject. Okay, you can use observer and then display in different form of object, of another object. Okay, to use the pattern in your design, you need to recognize that any design problem you are facing may have an associated pattern that can be applied. You can use when it depends on your skill and your experience also, right? You may face a problem, but you may not know this is their pattern. Someone already solved the problem already, but you try to solve by yourself. This is become a trouble for as an engineer, software engineer. So you have to look back to the existing pattern that someone already faced the problem, and then they try to solve the problem. Okay. There are another. For example, here there are many. They show the pattern. If you face this problem, what thing, what pattern that is suitable for you. For example, tell several object that the state of some to another some other object has changed. We can use observer pattern. Tidy up the interface to a number of related objects that have often been developed incrementally. Okay, we can use facade design pattern. Okay, then so on. There are many patterns over there. As I will show you here, this is my thesis implementation. The pattern. Okay, if you look at here, we have a controller, we have service, and we have repository, right? You look at the controller, we have controller A, B, C, and controller N, so on, and controller N, right, and so on. Every controller they need they use many services, right? For example, controller A may use service A, B, C, and N, right? Controller B may use another service, right? You see the arrow is complicated to managing. Okay, I want to solve this problem. I want to make some kind of the middleman, a person or a class or object that managing this thing. Okay, to managing this thing. So there are pattern. We have to look back at the pattern that already exists or not. If not exist, so we can create our own pattern, or we propose our own pattern. But according to this problem, there may some kind of pattern that will be what we say, help us to do this one. As you look this one, you see that the line number 3, tidy up the interface to a number of related objects that have often been developed incrementally. Okay, if you face this problem, okay, there will be many interface that from different controller to the service, right? They are using many connection like this. So better we can use the facade design pattern, right? To summarize, you see this one, facade design pattern, right? You see this one? From facade to class A, class B, and class C. We can summarize the class A. We can access class A, B, C, D via facade design pattern. That the facade design pattern used to access via the interface to the class A, B, and C, right? So we can implement to, or the system will be look like this. We initiate another package. That package will be include the facade services, okay, that implement the facade design pattern. So every controller need to use services. You have to use facade services, okay, facade services. So the facade services will help the controller to access the service based on the request and response, okay. It will make the code more organized, okay, more organized and easy to understand the code, and the code is more managing, okay. Implementation issue, okay, implementation issue. When we try to do the implementation, there are some kind of issue that we have to discuss first, okay. This is experience, lesson learned from the previous software engineer and developer. Focus here is not on the programming, okay. This is but it's important. Implementation issue that often not covered in the programming text. If you are doing about programming, there may another issue. For example, there are error, some kind of human error or syntax error. But this is about high level of the implementation issue that we're going to discuss. Three things here. There is first is about reuse. The second is configuration management, and the third is host target development. Okay. If we look at the reuse, modern software, most modern software is constructed based on the existing component or system. Mean that they do not build from the scratch. They do not start to build from the zero. Okay, but they are building from something that already exists over there. Okay, that we call a component, that take many components combined together and create such application of system. We have one process that we call component-based development. Okay, component-based CBS, right? CBS. Configuration management. During the development process, you have to keep track of the many different versions of each software component in the configuration management system. You have to keep tracking. We keep tracking from the requirement, right? By using such version control. Okay, version control such as Git. Okay, we tracking the version of requirement, right? Requirement may change. Okay, from this point to another. Then we can roll back if there is something what we call unexpected. Okay, in implementation also we have to do the version control. Okay, keep tracking the thing that happened. Okay, especially the code itself. Okay, there should be a version of the code. Okay, there should be what we call documenting the code and so on. Host target development. Production software does not usually execute on the same computer as the software development environment. Rather, you develop it on one computer, the whole system, and execute it on a separate computer, the target system. Okay, you are not developing alone, right? You may developing several person, right? Several person may stay in different places, right? So there should be the host target development, right? There should be the target user that you're going to develop. For example, and also when you develop in Windows platform, right? When you want to use in the Mac OS environment in another, right? If I develop any application in the Mac OS, I have to make sure there is will be run also in Windows. Okay, in terms of web application, for example, when you use a browser, right? Different browser, there are different engine behind, right? For example, Safari using WebKit, okay, another Chrome, they may using another web engine over there. So when you develop using Safari's browser, so you had to check also on another environment, for example in Chrome or Firefox, that can be run also, that will be run correctly, okay. We will say host target development. Let's see the reuse, okay. Reuse is not new thing, okay. It's not new thing. Most of right now we are developing based on reuse, okay. When you use something, okay, a library or component, that is we call reuse, okay. By my personal development, okay, I do not start from scratch. We have to look back to the existing component or library that can helping us, that we call reuse, okay. Reuse can be reduce the cost because of what? Because it can be reduce the time of development, right? You don't need to start from the zero, right? You will start from something that already exists. Okay, for example, you don't need to design the login system because someone over there already do the best practice login system. You can download the component and use it. We call reuse, okay, via the interface, okay. This is we call reuse. Reuse level, there can be reused with several levels. You can see here abstraction level, object component, and system level, okay. Most of we are talking about object and component level, right? We are talking about the class. You can reuse library, you can reuse class, you can reuse component as any component. When you use the dependency management as a composer or npm, you can install any library from the existing library to your project, and then you can reuse, okay. This is the example of reuse in terms of object level and component level. Software reuse can be reused component, can be reused system, can be reused abstraction, architecture. For the patterns, for example, the pattern is you reuse, okay, because you do not try to create your own, but you try to use the best practice, right? We call reuse. Programming language library, okay, we reuse this one. You are already familiar, but you already use this thing, but you may not know that you are using the reuse concept, okay. When you download some kind of a library, for example, a Bootstrap, okay, Laravel framework, PHP, Laravel, or Python, the Django, for example, this one you try to implement the reuse concept via the component framework, okay, a component framework or library framework. Because of reuse can be reduce the cost, because when you reuse, you don't need to do the coding at all thing, right? You can start from what we call focusing on your business domain, and then you can develop it, so it will be reduce the cost, okay. This is the reuse. Configuration management. Configuration management is the name given to the general purpose of managing a changing software system, because when you develop software alone yourself, you may confuse about version, because of there may many feature, okay, many feature over there, many features or over there. So how to manage that feature? What this feature? For example, we have feature A, B, C, right? You're developing about feature A, and then you try to develop another feature B. So without any configuration management, you will be confused about what the progress of the feature, what the code is about this one, and what is the commit, the change of that code. Something like this is about configuration management. The aim of configuration management is to support the system integration process, so that all developers can access the project code and document in a controlled way without find out what change have been made and compile the link component to create a system. This is the aim of configuration. Because it's not the software development is not about designing and coding and then implementation, but also testing and validation. They have to have any kind of library that tests you, okay. You may not know what component already test, okay. If you wanna retest what the thing that I had to retest, this is also about configuration management will guide you what thing that you have to do, okay. Configuration management, activity. There are three main activity that used to do with the configuration management. First is version management. Okay, that we are using version control to keep tracking the different version of software component, okay, or the code. Okay, and another is system integration, because one system will develop by several people, several developer, right? So to integrate, okay, to take the system integrate to each together, this is we have to do configuration. How can we integrate the system to make it work together? Okay. Problem tracking, this is also one thing that we can use configuration management. For example, you do about this thing and then you face a problem and then you try to propose help, asking help or providing the solution to that problem. You can say this is a problem tracking. In real life, we use the GitHub issue to example as GitHub issue to use for problem tracking. Okay. For example, you see that this feature is have any kind of error. This requirement is impossible to what we call to do coding. So you can open the issue on the GitHub, for example, to show that this thing is error over there. How can we solve the problem? What the solution, right? This is we call problem tracking. We are the example as GitHub open issue. Configuration management tool interaction. For example, here you can see we have the component version, so our code, right? So we start to build, okay, system building. Okay, it will become system version. If there something change management, they are change or not, it's not change, so system release. Okay, if there are something change management, so we have to release management. Okay, from component version to system version, there are version management. Okay, version management to take control of the version, what version that going to be the version of the system. Okay, if you compare this one, you can compare to the what we call DevOps. There are more deeper explanation about this thing, because DevOps will explain you most entire life cycle of the configuration management from what we call using version control to testing to integration and so on. Host target development. Most software is developed on one computer, the host, but run on separate machine, the target, right? So they should be considered also about this thing when you develop some kind of software, right? You are using Windows, I'm using Mac, so you have to be able that what system you are developing. Okay, especially the native application. If you are developing for web application, I think there will be no much issue, but it will be a small issue such as web browser compatibility. Okay, you may use Chrome, I may use Firefox, for example. They may an issue over there, but in general there will be no much issue except something that is specific function. Okay, as some kind of display animation or text or animation or graphics, something like this. Okay, because there are different web browser, different engine behind. Okay. Target development. For example, you are developing on the host, and then you deploy to the target execution platform. Okay, the target can be right now the most famous one is Kubernetes. For example, can be used for execute your code to store your library and related system and database and so on. In your computer, you will install IDE, compiler, and testing tool. Okay. Mostly this is for developer. They will install IDE. Okay, integration development environment and compiler mean that they used to compile from computer language from syntax to computer language. Okay, testing tool to test the function, to test the feature that is working or not based on the requirement. Okay. Development platform tools such as integration compiler, syntax direct editing system that allow you to create, edit, and compile the code. Okay, this is mostly is about IDE. Okay, integration development the environment, the language debugging system. Okay, the system that used to debug your code. Okay, the system that debug your code. There are many over there. Graphical editing tools such as to editing UML model. Okay, you can use many tools to editing graphical, because you are doing coding by using graphical is more easier, because you can see the graphical in terms of, for example, a use case diagram, and then you can do the coding follow the use case diagram. Okay, testing tool such as JUnit, for example. There are many tools for JUnit is for Java, and PHP unit is for PHP, and so on. Okay, to testing the code is working or not. In terms of unit testing, okay, in terms of unit testing mean that you're testing the class diagram, class code. Okay, project support tool that help you organize the code for different development project. Okay, we have the many project tool. Okay, we have Microsoft, we have in the free one is you can use the GitHub project. Okay, GitHub project is we provide you the project can managing the requirement, and then who responsible for this requirement. You can use Stack Overflow, you can use Slack, you can use Trello, and so on. There are many tools over there to support you about project management. Okay, mostly developer is familiar about IDE, because we doing coding in the IDE, right? You may use different IDE. For example, you use IntelliJ IDE. You may use NetBeans. You may use whatever. You can use Eclipse, for example, and so on. There are many IDE over there. You are developed by using, as me, develop using PHP. I'm using PHP Storm as my IDE. You can transform your VS Code, okay, to be IDE by installing some kind of plugin. Okay, the IDE is a set of software tools that support different aspects of software development within some common framework and user interface. IDE are created to support developer development in specific programming language such as Java and so on. And then there are multi-purpose IDE. Actually, they are the multi-purpose to use. Okay. There are a component and system deployment factor. When you want to deploy some kind of system, okay, or software, better to deploy by using a component or system. Why? Because you can provide the interface, and then it can be given to another people, not editing your code, but they request to use the code. Okay. If a component is designed for a specific hardware architecture or rely on some other software system, it must obviously be deployed on a platform that provides the requirement hardware and software support. Okay, when for example you're doing coding for IoT, for example, so your component, your system should be able to run, okay, on the IoT platform. Okay. High available system may require a component to be deployed on more than one platform. Okay, because one high available system means that the system that available every time. The system huge, people use a lot. Okay, they need to make system that reliable. So a component can be deployed to many hosts. Okay, they not just only rely on just only one host. Okay, because they want to do the what we call tolerance. Okay, make the component available at any time. If the component on this server is not available, we can use the same component on another server. Okay, this is what we call high availability system. Okay, more resource about the design pattern, about this topic, about design and implementation, especially about design pattern. You can read this book. Okay, Element of reusable object-oriented software by Eric Gatma. Okay, because this is the original book of the design pattern. Okay, so you can, if you wanna relate it about UML and pattern, read this book. Okay, applying UML and design pattern and introduction to object-oriented analysis and design iterative development. Okay, so the example over there about my thesis, you can download my thesis according to this. Okay, you can search on the Google, it's available online. Okay, it's free. Summary. Software design and implementation are the process that will happen after we already analyze of the requirement. Okay, the level of detail in design depends on the type of system and whether you are using a plan, drive, or agile approach. It depends. Okay, the process of object-oriented design include activity to design the system architecture, identify object in the system, describe the design using different object model, and document the component interfaces. Okay, a range of different models may be produced during an object-oriented design process. This include the static model and then also dynamic model. The static model can be class model, generalization model, association model. In dynamic can be sequence, state machine, and so on. A component interface must be defined precisely so that other project can use them. Okay, in UML interface, stereotype may be used to define the interface. Okay, better to use some kind of UML notation to represent the component interface that to talk to another people at the same language. That is UML. Okay. When developing software, you should always consider the possibility of reusing existing software, either as a component service or complete system. When you start to develop something, you should start from looking at the component, the requirement, right? When you look at the requirement, you see that this requirement is component over there is already available or not. For example, login, register, and adding, deleting something is available or not. Component over there, it already exists or not. If it already exists, so better to reuse. Okay, it's better than you create things from the scratch, because of what it will take time and budget a lot. Okay, configuration management is the process of managing change to an evolving software system. It is essential when a team of people are cooperating to develop system. Configuration management is very essential. We are working software together. For example, 2 or more person together, or 10 person, 100 person working in the same code base. It's better to set a configuration management such as version control, system integration, and so on. Most software development is host target development, mean that you develop in one computer and deploy to another. Okay, you use an IDE on a host machine to develop the software, which is transferred to a target machine for execution. You develop something in your computer, and then when you execute already, you send to the user to use the software, or you develop the code in your computer and then you put it on server. For example, the web application, right? You develop on your computer, and then when you want to deploy, you deploy on server. This is called host target development also. Okay, this is about software design and implementation.